Hi, my name is Rene Domínguez, and I'm working in Electrical and Electronics Department at Autónoma University of Tamaulipas in Mexico. It's a pleasure for me to present our paper in this important conference. Well, let me share the screen. And fix. Okay. Well, our contribution is named Fiber Optic Sensor based on Fluorescence Quenching for heavy metal detection. This is a collaboration between the sensors group of the Public University of Navarre in Spain and the Autónoma University of Tamaulipas. Our motivation is based on ecological disasters are topics that matter in different areas of science and engineering. In this sense, polyurethane monitoring should be done in real time at low cost. Fiber optics sensors should be an attractive option. For this reason, we propose to use the metal with coating on the tip of a multimode fiber optic. Then we use the structure for the detection of mercury. First of all, we have some considerations. We start from the fluorescence effect. It's possible to induce a fluorescence signal from a pumping beam, like in this picture. In particular, authors have reported that a methyl red fluorescence peak appears around 365 nanometers. This signal was monitored using conventional spectrometry mechanism, like shown in this schema. However, the fluorescence is absorbed in the presence of mercury particles. This effect is commonly called fluorescence quenching, and it depends on the concentration level of the mercury. From this consideration, we propose to place a methyl red coating on the tip of a conventional multimode fiber. Later, we immerse the end on a fiber in aqueous solution and induce a fluorescence signal like this. Then we establish the experiment. For first step was a sensor build. We use an uncoated multimode fiber with a straight cut and the tip. Then we using a deep coater system, and the fiber was immersed in the solution. This solution was preparing with methyl red, ethanol as a solvent, and a polyurethane thermoplastic TPU. TPU was used to fix the coating on the end of the fiber. The sensor head was placed into the oven like this to evaporate and evaporate the remaining solvent under this process. Then the next step was testing the device. This system consists of a laser diode centered at 365 nanometers as the pumping light source. The laser diode is connected to a 3 dB fiber coupler. The optical signal propagates along the coupler to reach port 3, where the sensor head is placed, here. The fluorescence is stimulated and travels back through the coupler, following this line. Okay. In this graph, the back line corresponds to the pumping signal from the laser diode. In red line, we observe the fluorescence signal induced in the sensor head and collected in port 2. Then we prepare 4 different concentrations of mercury in buffer solution, as is shown in this table. These solutions are used to test the sensor device. In the next graph, here, we observe the fluorescence signal detected, but now the sensor head is immersed in each mercury concentrations. We can observe the fluorescence quenching signal when the mercury concentration decreases for each one. For a better description, we consider the Stern-Bolmer equation. From the experimental data, we use the rate maximum of the fluorescence peak and the maximum intensity in the pumping beam. The calculation shows approximately a sublinear relation between this radial and concentration levels. From this figure, we observe the last point, this, do not maintain linear shape. We suppose that is an error in the process of fixing in the pH level. Also, we observe for the high levels of mercury concentration, the pH is changing along the time, probably due to a chemical instability. In partial conclusions, we report the process of attaching of methyl red coating to the conventional multimode fiber tip applied as a novel sensor. This system is able to detect mercury concentrations in aqueous solutions and in a reflection geometry. The next step, we increase the range of the mercury concentration and optimizing the construction process. Thanks for your attention. Thanks for the organizing committee, and it's a pleasure to be in this conference. Thank you very much, and see you soon.